All right, let's look at the algebraic operations on functions. All right, so when you have f plus g of x, this simply means that take f of x and the g of x added together. All right, and f minus g obviously means f of x minus g of x. Right, fg of x is f of x times g of x. Right, and f over g of x is f of x over g of x. Right, very natural. Right, then when you look for the domain of these functions, let's say d sub f is a domain of f, function f, and g sub g would be a domain of g. Then when you look for the domain of these addition, subtraction, and the multiplication, domain is determined by this. Since both functions have to make sense, so we have to make sure that if you want to find the domain of f plus g, which is actually exactly the same thing as domain of f minus g, and also the same as f of f sub g, domain of f times g, and this is simply the intersection of those two domains. You have df intersect dg, which makes sense, right? Because those two functions have to make sense at the same time, right? Then only difference is f over g, right? So if you want to find the domain of f over g, then of course it has to be inside the domain of f at the same time domain of g, right? But there's one more thing we have to worry about, because it's a fraction, that we have to make sure that the denominator is non-zero. So we have to make sure that here, this is a notation, so it's all the x values such that g of x, which is the denominator, is not equal to 0. So there's a one extra condition involved there. All right, so let's look at the following example. F of x is equal to square root of 3 minus x, and g of x is square root of x squared minus 1. All right, let's find the domain of each one first. So domain of f would be, right, so we want 3 minus x to be non-negative, so it has to be less than or equal to 3. So we know that, let's see, we're talking about the x is less than equal to 3, so 3 is the highest one. We include 3, and anything below would work. All right, and the domain of g would be, all right, so let's say x squared minus 1 has to be non-negative, so smallest could be actually, it has to be less than or equal to negative 1, or greater than or equal to positive 1. So it's going to be negative infinity all the way to negative 1, and 1 and all the way up. All right, so that's the domain of the function g. All right, so let's find, for example, f plus g. So if somebody says find f plus g of x, right? That's simply the addition between these two functions. So you have square root of 3 minus x, and then you have a square root of x squared minus 1. So it's very, very easy. And if let's do just one more. So if you want f of g, f over g of x is simply square root of 3 minus x goes on top, and the square root of x squared minus 1 goes on the bottom. So that's how you create the addition and the division here. All right, the more interesting problem would be finding the domain of these two guys. All right, so in order to find the domain of, for example, domain of f plus g, right, which is exactly the same as domain of f minus g, and the domain of f times g, right, would be an intersection of these two sets here, right? So let's draw a number line so that we can kind of visualize what's going on here. So here's the number line, right? So it's less than or equal to 3. So we have 3 here. And it has to be less than that, less than or equal to that. So I'm gonna put so I'm gonna put a solid dot because there's a equality there. 3 is included. So this is f of domain of f. All right. Then domain of g is less than equal to -1 or greater than equal to +1. So +1 would be probably here, and -1 would be probably here. Then we're talking about these guys. All right. Right, so we're looking for the intersection of those two guys. So you can see that the intersection would be, so common part would be, of course, these between 1 and 3, and also less than or equal to -1. All right, so you can see that the domain of all these guys would be -infinity to -1. Inclusive, and also between net 1 and +3, right, including endpoints. Right, so that's the domain of those three guys: addition, subtraction, and the multiplication. All right, how about the division? F over g of x. Right, so only difference is we have to make sure that the g is non-negative. So we have a g of x. Okay, actually, I should say non-zero, not the non-negative, non-zero. So we have to make sure that the square root of x squared minus 1 cannot be equal to 0. All right, so we have square both sides. So you have x squared minus 1 cannot be equal to 0. All right, then this means that let's see, add 1 to both sides. So x squared cannot be equal to 1. All right, then we can take the square root of both sides. So you have x is going to be equal to square root of 1 is 1, but the plus or minus. So x cannot be equal to +1 or -1. Right? So what we need to do is, since -1 is included here, and a +1 is also included here, so we have to make sure that when you look for the domain of f over g, this would be from -infinity to -1. But instead of the square bracket, we use right parenthesis to exclude -1. And the same way, we use the left parenthesis to exclude 1, but the 3 is still included. All right, so those guys, so this is the domain of the first 3. And this is the domain of f over g. All right, that's it. I hope that this was clear.